This is the start of section 8.4, properties of logarithms. There are three basic properties that you should know when working with logarithms, and those are as follows. For any positive numbers m, n, and b, with our value of b here not being 1, then log base b of m times n is equal to log base b of m plus log base b of n. So the first property, log base b of m times n, is equal to log base b of m plus log base b of n. So that'll be the first property. Then the second property is log base b of m divided by n, which is simply log base b of m minus log by base b of n. So log base b of m divided by n equals log base b of m minus log base b of n. And then the third and final property is log base b of m to the x power for some value of x. That means log base b of m times x, m to the x power, is the same thing as saying x log base b of m. There are technical terms for each of these properties. This first property here, log base b of m times n, is known as the product property. Log base b of m divided by n is known as the quotient property. And then the last one, log base b of m to the x power, is known as the power property. So just to recap the product property here, log base b of m times n is equal to log base b of m plus log base b of n. Quotient property, log base b of m divided by n equals log base b of m minus log base b of n. And then the power property is log base b of m to the x power equals x times log base b of m. And then one last property that we've talked about in section 8.3 is the fact that exponential functions and logarithmic functions are inverses of each other. So if we raise a to the logarithm with base a of some value b, then the exponential and logarithmic will cancel, just giving us our b value. And the same is true for our when we take a logarithm with base a of some value a to the bth power. The logarithm and the exponential part will cancel, leaving us with our exponent b. So those are four general properties that you should familiarize yourself with for this section. So here are three quick examples of identifying properties of logarithms being used. In example A, we have log base 2 of 6 plus log base 2 of 3, giving us log base 2 of 18. Remember, 18 factors as 6 times 3, so you can get, this can be expressed as log base 2 of 6 times 3. Well, that looks a lot like the product property, so you can split it up as log base 2 of 6 plus log base 2 of 3. So therefore, example A is the product property. For B, you have log base b of 3 to the 4th power. Well, you have something raised to the 4th power. The 4 comes out in front. So this looks like the power property. And for the last one, you have log base 3 of 2 divided by 3. Well, 2 divided by 3, you get log base 3 of 2 minus log base 3 of 3. That is the quotient property. Now, something with this last example here, if you were to take this and expand it, you get log base 3 of 2 minus log base 3 of 3. This log base 3 of 3 is just 1, so you could technically, in fact, write it as log base 3 of 2 minus 1. But for our purposes right now, just as long as you know, can differentiate between or identify the properties of logarithms being used, in this case, for example, A, it's the product property, example B, it's the power property, and for example C, it's the quotient property. That will be quite sufficient. So now, let's take some more examples here and apply these three properties that we know. And let's write these two examples here as a single logarithm. So we have log base 3 of 20 minus log base 3 of 4. This looks a lot like the quotient property. So in this case, you just take it and say log base 3 of 20 divided by 4. This can simplify the 20 over 4. So you're just left with log base 3 of 20 divided by 4, which is 5. So that's how you would write example A as a single logarithm. Log base 3 of 20 minus log base 3 of 4. You just divide the 20 and the 4 because there's a minus, and you get 5. For example B, you have 3 times log base 2 of x. That immediately tells me that there's going to be a power property. And after that you have a plus log base 2 of y. So you're going to have the power property and you're going to have the product property. And the way you would do this is you would do the power property first and then apply the product property. So in this case you would do the power property first to get log base 2 of x cubed plus log base 2 of y. So that takes care of the power property, and now you have to take care of the product property. And when you do that, you have x cubed plus, you have log base 2 of x cubed plus log base 2 of y. You can just write it as log base 2 of x cubed times y. Just like that. So the last couple of examples, the last two examples, we wrote logarithms as a single logarithm. Now we're going to take single logarithms and expand them. And this is how you would go about doing that. Example A, you have log base 5 of x divided by y. Well, that x divided by y looks a lot like the quotient property. And if you remember what the quotient property is, you take log base 5 of x divided by y and just make it as log base 5 of x minus log base 5 of y. And that's all you have to do for example A, because it's just using one property, the quotient property. Part B, for example B, you have log of 3 times r to the 4th. Well, 3 times r to the 4th, that's a lot like the product property. And then you have 3 times r to the 4th, so that r to the 4th will indicate you will have a power property. And what you do is, once you identify that you have a product property first, you would apply the product property rule first, and then do the power property. So you would get log of 3 plus log of r to the fourth. That takes care of the product property first. And now take care of the power property and log of r to the fourth to get log of 3 plus 4 log r. Pretty simple stuff here. So then the last one, a little trickier, example C, log of quantity y divided by 3 squared. In this case, you might be tempted to take the quotient property, and I can tell you that you will be doing the quotient property, but because you have the y divided by 3 in parentheses, raised to some power, you have to do the product property for the power property first. And then once you take care of the power property, then you could work with the y divided by 3 and do the quotient property. So then when you do the power property first, this 2 comes out in front of the logarithm to get 2 log of y over 3. And now, since you've taken care of the power property, you can take care of the quotient property and make it 2 times log of y minus log of 3. And I'd put these in parentheses, the log of y minus log of 3 in parentheses, because you're multiplying log of y over 3 by a factor of 2. So I would keep this rule here in parentheses so you can differentiate between the 2 times, because you might be tempted to write 2 log y minus log of 3, which is not equivalent to what it should be. This looks like 2 times log of y minus log of 3. You really have to differentiate between or put the parentheses around to know for it to actually mean the same thing. For these two to be equivalent, you have to use parentheses. These two are not equivalent. But if you wanted to, if you had it at this step and you wanted to take it to 2 log y minus 2 log of 3, you can do that. You can do that if you want, but just know that if you get to here, I will be all right with that. And that is all of section 8.4. Nothing too overly dramatic, nothing too overly complicated, just using some properties of logarithms, or learning 3 different properties of logarithms, and using those to expand logarithms or write them as a single logarithm, or just to identify properties of logarithms being used. The next part of this video is going to be a few try problems for you to try on your own that I encourage you to do upon completion of the video.